Today we'll be looking at Lesson 9, Tables of Equivalent Ratios. We'll be learning about ratio tables today, or just tables that show a set of equivalent ratios in a nice orderly fashion. So let's look at example 1, and we can see how a ratio table works. To make paper mache, the art teacher mixes flour and water. For every 2 cups of water, she needs to mix 3 cups of flour. Find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. So, here we have our blank table to fill in. Our first ratio we're going to use was given to us of 2 cups of water to 3 cups of flour. So we're going to fill in our 2 cups of water and our 3 cups of flour. And now we've got to fill in 4 more sets of ratios. All the ratios in this table need to be equivalent. In order to create an equivalent ratio, remember we need to multiply or divide both numbers in the ratio by the same thing. So, I like to pick easy numbers. So I'm going to start with an easy number of 2. I'm going to multiply the first number by 2. 2 times 2 is 4. Now I'm going to multiply the other number by 2 times 2. And I'm going to get 6. Okay, then I did 2. Let's do 3 next. I'm going to do 2 times 3, which is going to get me 6. 3 times 3 is going to get me 9. And you can kind of see where we're going next. Next I'll do 4. 2 times 4 is 8. 3 times 4 is 12. And then last we'll do 5. 2 times 5 is 10. 3 times 5 is 15. Now you could have picked any numbers to multiply by. I just picked the smaller ones because I think they're easier. Sometimes you might need to pick different numbers based on the situation. Some situations might require you to pick certain numbers so that your table can be useful to you in helping you solve a problem. But if it's not necessary, I would suggest picking small, easy numbers to multiply by. Let's look at another one. Javier has a new job designing websites. He is paid a rate of $700 for every 3 pages of web content that he builds. Write a ratio table to show the amount of money Javier has earned to the number of pages he has built. So here we go. Here's our table. How many pages has he built? Well, the ratio they gave us is he builds 3, and that gives him $700. Okay. So then, from there, we can just pick our numbers to multiply by to make more equivalent ratios. Again, smaller, I think, the better. So let's do 2. 3 times 2 is 6. 700 times 2 is 1,400. Let's do times 3. 3 times 3 is 9. 700 times 3 is 2,100. And so on. Times 4 will be 12, and 2,800. Times 5 will be 15, and 3,500. Times 6 will be 18, and 4,200. Times 7 will be 21, and then 4,900. And then by 8 will be 24, and 8 will be, and then 700 times 8 will be 5,600. There we go. Now we got our ratio table filled in, so all of these ratios in this table are equivalent. So all of them match up or have the same value as our original ratio of 7 to 300. Now let's look at what the question is asking us to solve using this table. Javier is saving up to purchase a used car at $4,200. How many web pages will Javier need to build before he can pay for the car? Well, let's look up at our table. We're looking for money, so we're going to look in the bottom row. Now we're looking for 4,200. There's 4,200. How many pages will he need? Well, he'll need 18 pages. So you can see how our table helped provide us with the information we needed. Okay, let's look at another example. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on plants. It is made by soaking cornmeal in water and using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table to answer the questions that follow. Well, let's start with our original ratio. Original ratios for cornmeal is 2 cups cornmeal to 9 gallons of water. So there's our original ratio. Now to fill in the rest of our table, let's use equivalent ratios by multiplying by the simple numbers. 2 times 2 is 4. 2 times 9 is 18. 3 times 2 is 6. 3 times 9 is 27. Next we multiply by 4. 2 times 4 is 8. 4 times 9 is 36. Lastly, we're on 5. 5 times 2 is 10. 5 times 9 is 45. So let's look at the question they want us to answer. How many cups of cornmeal should be added to 45 gallons of water? Well, we're looking for gallons of water. We find 45. How many cups of cornmeal? There's 10. So we need 10 cups of cornmeal. Okay, so there we go. Our table made it real easy to figure out. Now we can look at this next one. Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? This time we have given cornmeal, so we follow down the cornmeal until we find 8. Go over and we see, there's 36 gallons of water. There we go. So it's really easy again using our table. We can find it if we're given either the cornmeal or the water. Lastly, what can you say about the values in the ratio table? We can say that they're all equivalent. Since we always multiply by the same number on both sides, they are all equivalent ratios, so all the values in the table are equivalent. Okay, let's look at one last one. James is setting up a fish tank. He is buying a breed of goldfish that typically grows 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water to fully grown goldfish in the tank? Complete the ratio table to help answer the following questions. Well, the number of fish, let's start with just one fish. Now, how many gallons of water is one fish going to need? Well, if the fish is going to be 12 inches long, and there's 1 gallon of water for every inch of fish, then it should be 12 gallons of water. 1 for each inch of fish, which is 12. So one fish is going to need 12 gallons of water. Well, if we double that, 2 fish is going to need 24 gallons of water. 3 fish, multiplying by 3, is going to be 36 gallons of water. 4 fish is going to be 48 gallons of water, multiplying by 4. And 5 fish is going to be 60 gallons of water. Now we have our table filled in. Let's use it to answer our question. What size tank in gallons is needed for James to have 5 full-grown fish? We go to the fish column, down to 5, and what gallons of water? 60 gallons. Okay, let's look at the next one. How many fully grown fish can he get with 40-gallon tank? So we go to gallons and we go 40. There is no 40. So you got to figure out where would 40 fit in. Well, 40 would be between the 36 and 48. Well, how many fully grown fish can he fit? He couldn't fit 4. 4 would need 48. So we got to go down. We're going to have to go down to 3. So 3 fully grown fish can fit in a 40-gallon tank. 4 would be too much. You would need 48 gallons for that. So he can only have 3 fish. And lastly, let's look at what can you say about the values in this table. Well, it's the same as last time. Any ratio table, they are going to be equivalent. All the ratios in a ratio table are equivalent because you multiply by the same number on both sides as you move down the table or across the table, meaning all the ratios inside the table have the same value. So that was our introduction on ratio tables. Remember, a ratio table is just a table of ratios that are all equivalent that you can use to help you answer problems about an original ratio and its other forms.